Here we go, Module 3. Buckle up and let's get ready. Alrighty. So take out your notes and we'll start off right away while I get this all set up here. Oh, I want my ink. Hang on. Here we go. All right. So our essential question is, how do I convert rational numbers into decimals? Question mark. All right. So I want to review a little bit. Some of these terms might be familiar. We're just going to kind of put a brief word definition, and sometimes we'll add some more to it as well. So if you remember how we defined integers in Module 1 and 2, is we said it is all of the whole numbers. That means no decimal parts, no fraction parts, and their opposites. Now, I don't know about you. As much as I like word definitions like this, it helps me if I can write it down and show it as well. Okay, so underneath here, will you start by listing the whole numbers 0, 1, 2, ... The whole numbers go on into infinity. And then if I have to include their opposites, well, the opposite of 0 is 0. The opposite of 1 is -1. Opposite of 2, -2, ... So not only does the list of numbers go on into infinity in positive land, but it also goes in negative land as well. So we have lots of integers. You could never count them all. Okay? Never count them all. So now we've got to tackle, what on earth do we mean by a rational number? Well, I think the easiest way that you can write it is as a ratio, which also means write it as a fraction. Two numbers being compared to each other by division. Okay? And here's how I'm going to write this, because there's just, if we thought there were a lot of integers, wow, decimals or fractions are just going to blow our mind this way, what rational numbers are. So rather than try to make a list, here's what I'm going to recommend. Write the fraction a over b, where a and b are going to be variables that represent different values, okay? And here's what I'm going to tell you about a. A can be any integer. In fact, I should put the word any up there, so I'm going to add that in. This is any integer on the top. It could be -5, could be 0, could be 263, any number that's an integer for the numerator. In the denominator here for b, there's just one little thing we have to add in here. So b is any integer except, there's one main exception. Do you know what it is? Not 0. Because being in the denominator means you're dividing by, and you can't divide by 0. So b is also an integer, any integer as long as it's not 0. Could be positive, could be negative, does not matter. A terminating decimal is a decimal that stops. Like 1/2, if I turn that into a decimal, it's 0.5 or 5/10, and it stops. There's no other numbers here. If I really wanted to, I suppose I could put zeros in forever, but it stopped with any significant digits, so we just stopped there, okay? This is rational, okay? So this number, you can write as a fraction, okay? So the decimal way of writing it is just another way to represent the same number. 0.5, which is 5/10, is exactly the same as the fraction 1/2 when it's in simplest form. The last one, this one that says repeating decimal, this is a decimal that repeats. It still is considered rational because we can write that repeating decimal, or it comes from some kind of fraction. So I always think of this one, 0.3 repeating. That actually comes from the fraction 1/3. Those are exactly the same. And notice we use that repeating bar. Hopefully you're used to seeing that and you've used that notation before, okay? All right, so now let's dive in and look at some things. All right, way back, 4th, 5th grade maybe, you started understanding that when your textbook writes 5 with the fraction bar 8, that's the fraction 5/8. Sometimes we write it vertically this way. That's easier to do by hand, not so much by computer. And it also means this, 5 divided by 8. Okay, so if I have a fraction, I can turn it into a decimal just by multiplying. All right, so I'm going to do this. 5 divided by, no, that's not it. Hold on. When you start saying it out loud, here's how I want you to think. 5, and then the divided by means the box, the division box goes around it. So say 5 divided by 8. There we go. 5 divided by 8. All right, ask yourself, can 8 go into 5? Put a 0 there. Can 8 go into 50? I'm going to have to keep adding zeros here until I either get a repeating pattern or it terminates and stops. So 8 can go in there 6 times. That's 48. 50 minus 48 is 2. 2 is smaller than 8. Okay, this is a remainder. I can't have that when I'm working with decimals. So we add a 0 and bring it on down. 8 can fit into 20 2 times. That gives me a remainder of 4. 4 is smaller than 8, so I'm okay, but I still have to keep going and add yet another 0. And now I'm going to say, oh, it can go into 40 exactly 5 times. When you subtract, I get no remainder. Now I'm done. So this fraction, 5/8, is the same as the decimal 625 thousandths. Lazy math people might say just 0.625, but realize the first decimal place is the tenths, there's the hundredths, there's the thousandths. Okay, so let's take a look at this chart here. As I'm looking, we just did 5/8, so I know that as a decimal, this is 0.625. Okay, 1/4. You might know that one off the top of your head. Do you? A quarter? Do you know how many cents is a quarter? You should get 25 hundredths, 0.25. Ooh, 2/3. God, I kind of want to talk about 2/3 because something kind of goofy happens with these. Okay? If I went to do 2/3, 2 divided by 3. 3 can't go into 2, so I put a 0, and then I add a 0 here. When I subtract, I get a 2. If you get a remainder, you have to add a 0 and keep on going. 3 into 20 is, 6 again. 6 times 3 is 18. 20 minus 18 is 2. I add a 0. See what's happening? This will go on forever. Here's our first example of a repeating decimal. Just list the first digit that repeats and put that bar on top. So this, I would read this as 0.6 repeating. Can't really say 6/10 repeated because this thing doesn't end in the tenths place. It keeps going, 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 and going. So we'll just leave it like that. Ooh, 2/9. All right. 2/9 means 2 divided by 9. Okay, so I'm gonna come over here. 2 divided by 9. Oh, watch what happens on this one. Can 9 fit into 2? Well, of course not. There's my decimal point. Add a 0. Subtract. I get a 2. Add a 0. 9 can go into 20. Wait a minute here. Oh, do you see what's going to happen? This thing also repeats. Little differently. I'm not getting 6s. I'm getting 2s each time. Write this as 0.2 with a repeating bar. Okay? All right, this one, 12/5. Take a look at that for a second because the numerator's 12, which is much larger than 5. Boop, 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 boop. That should tell you something. 12 divided by 5. 5 can fit in there this time. You are going to get a number that's bigger than 1. And hopefully you recognize that because this fraction is improper. I'm going to put my decimal point in here. I know that I can fit 2 5s in there to make a 10. I have a remainder. Keep going. Fortunately, we don't have to go too far because when I add that 0, this will fit in there exactly 4 times. I get exactly 20. My remainder is 0. 2 and 4/10. Make sure your decimal point's in the proper place. Now, how do we turn a decimal back into a fraction? Just read that number with the proper place value. This really is how we should read it. We should not read this as 0.2. No, we should really say that is 2/10. 2/10. Now, if you can simplify that, which I can because both of these numbers have a factor of 2, in simplest form, that's 1/5. On this one, oh my goodness, tenths, hundredths, thousandths. This starts out as 875 1,000ths. Okay? That, however, is not in simplest form. And once I start tackling this by factoring out a 5, factoring out another 5, you will end up in simplest form with the fraction 7/8. Cool. So basically, when we looked on the front page and we started talking about decimals, whether it's terminating or repeating, it does come from some kind of fraction. Sometimes it's easy to write that. Sometimes it's more challenging if it's a repeating one, but they do come from a fraction. Take a moment, pause the video, and read these two and jot down what you think. When you're ready, turn it back on. Take a look at this number, 0.1010010001000. Oh my goodness. Cool pattern, but it doesn't really repeat. The dots mean it doesn't end. So this is kind of a strange one. Do you think it's a rational number? Meaning, does it come from a fraction? I'm going to tell you that's a big old no. It's an interesting number, but it isn't one that we call rational, okay? And the reason is there is no fraction, or I can't write that decimal as a fraction. Okay. On number 2, do you think the negative sign affects whether or not it's a fraction? No. Okay. Remember when we determined the definition, we said this could be any integer, and a negative number is definitely an integer. Like in this case, -8. B just cannot be equal to 0. But other than that, something like -8/5, gosh, -8/5, you could divide that out and get -1 6/10. Okay, that's rational because I can write it in a fractional format, whether it's mixed number, improper, whatever. Okay? All right, now go ahead, pause the video, and go to town on these two with some long division so you can turn these into a decimal. All right, 5/16, 3,125 10,000s. Yes. 13/33. Holy cow. That's a mouthful. 13 divided by 33. 33 is larger than 13. Can't fit in there. But once I add a 0 and I multiply by 3, you'd get 99. Subtract, and I get 31. Holy cow, that's almost the same value. Add a 0. Now we have to figure out for 310. How many 33s go in there? 33, 66, 99, 132, 160, and so on. Okay. And this one ends up being 9 times because you get 297. When you subtract, you get 13. Moo. Woo-woo. When we add a 0 on here and you start calculating, you're going to say, well, it only goes in there 3 times because that's 99. And then I subtract, and I end up with 31, and I add a 0. And now I have 310 again. Do you see what's happening here? This is a big repeating decimal, and it repeats in a 2-digit block. Okay? So as you start to clarify and answer questions about, does this thing terminate? Remember, this is the word we use for a decimal that stops, and repeating one keeps going, but it repeats with the same digit or block of digits and continues that pattern forever. All right? So let's take a look at each of these. 4 7s. When you start subtracting these ones, go ahead, give that a whirl. I'm going to stop for today in your notes. This will be the part A video, and we'll continue on with these tomorrow. But I want you to start looking for a pattern to see, does this thing repeat? Does it terminate? Which way does it go? Check Schoology for your assignment. Good luck, and may the force be with you.